Hi students, today I have come with another new problem that is given in Irido. That is the arrangement shown in the figure. Once let us once see the problem. The arrangement shown in the figure 1.64 consists of two identical uniform solid cylinders, each of mass m, on which two light threads are wound symmetrically. Find the tension of each thread in the process of motion. The friction in the axle of the upper cylinder is assumed to be absent. So now let us take the diagram. If you see the diagram once, see. Now let me draw the diagram from side view. From side view, if I draw the diagram once, it will be like this. Here this is the upper cylinder, and to this upper cylinder, two strings are fixed now, and one more cylinder will be at the bottom of it. Okay, this is one more cylinder. Here actually two strings are here at the in between these two cylinders. There are two strings. Yes. So what is the tensional force here? 2T. Now he is asking us to find the tensional force only. Now let us take these two cylinders. How do they move when you just make them free to move? Then how do they move? The lower cylinder will unwind the string and it comes downwards, as well as the upper cylinder, it rotates from there itself. Am I right or not? It will rotate. The upper cylinder will rotate in the clockwise direction, if you observe, and the lower cylinder will turn in the anti-clockwise direction. Yes or no? Now let us take the free body diagrams of these two now. Let us take the lower cylinder. On this lower cylinder, what are the forces that are acting on it? First one, mg in the downward direction, and in the upward direction, 2T tension is acting. In the upward direction, 2T tensional force is acting. Okay. So because of this 2T and mg, there is a translational motion in that lower cylinder. Am I right or not? Downward force is mg and upward force is 2T. So because of these two forces, there is a translational motion in that lower cylinder. So how do we write the equation for the translational motion in the lower cylinder? Now let us write in the lower cylinder. Let us write the equation for lower cylinder. Okay. So for lower cylinder, the actually its center of mass comes in the downward direction, right? Because of two forces. mg is downwards minus 2T is upwards. Am I right or not? mg is downwards and 2T is upwards, which is equal to mass into acceleration. Mass into acceleration. What is this acceleration? This acceleration is acceleration of center of mass. This acceleration is acceleration of center of mass. Here AC is equal to A. And now one more thing. Let us consider this is equation number 1. Okay. Now let us take the second. Now we need to take another equations. From where do we get these equations? Now these two are rotating. The two cylinders are rotating, right? Now let us take lower cylinder. And why is it rotating? Because of torque acting on it, right? Because of torque acting on it, it is rotating. Okay. So if we consider its rotation, so let us write the torque equation for lower cylinder. Okay, let us write the torque equation for the lower cylinder. Then what is the force acting on it? In the upward direction, which is rotating actually. 2T force, tensional force is rotating that object, right? So 2T into R is equal to 2T into R is equal to 2T into R is equal to I alpha, right? I into alpha, according to Newton's second law, right? Torque is equal to I alpha, like force is equal to mass into acceleration. Consider it is alpha 1, alpha 1. Let us take this equation. From this equation, now what am I going to write is alpha 1, I am going to write that is 2T into R divided by I value. Again, let us write I value 2TR divided by, what is I value here? MR square by 2, because it is a solid cylinder. It is a solid cylinder. Hence, what am I going to get? 4T by M into R. 4T by M into R, right? Now, let us take the torque equation for the upper cylinder. For the upper cylinder. For the upper cylinder, let us write the torque equation. So, the upper cylinder is only rotating. It's not translating. It is not in translatory motion. Its center of mass is at the same position, right? So, therefore, I'm going to write the torque equation for the upper cylinder as again 2TR, because even upper cylinder also is rotating about its own axis because of 2T tension, right? So 2T into R is equal to I into alpha 2. Now again alpha 2 is equal to again 2TR by I. Similarly, this also I am going to get 4T by MR. I'm going to get this also as 4T by MR. Okay. Now, again, so we have got alpha 1 value, alpha 2 value, as well as this is equation number 2, alpha 1 value, and alpha 2 value is equation 3. See, we have got 3 equations. So 3 equations, and we don't know what is alpha 1, what is alpha 2, and what is tensional force, right? These and acceleration. There are 4 unknown variables. What are they? That is tensional force we don't know. Am I right or not? Acceleration we don't know. Alpha 1 we don't know. Alpha 2 we don't know. But we have got only 3 equations. From where do we get that another equation? This is constraint relation. This is constraint relation. Constraint relation means what? Really, we are deriving the relation between the accelerations. So let us write that constraint relation. See, in this constraint relation, what are we going to understand is, let us take the 2 points. This is point P. Observe the diagram. And let us consider the point Q here. Are you observing point P and point Q? Yes. So at point P and point Q, okay, we can say that the accelerations of point P and point Q are same. Here we need to write a note here. The accelerations of point P and Q are equal. Accelerations of P and Q are equal. So, according to this constraint relation, how to write these accelerations? Now, acceleration at point P, let us write first. Acceleration at point P. Okay, acceleration at point P. See here, there are 2 types of accelerations. One is downward acceleration, that is acceleration of center of mass, and the other one is upward acceleration, that is R alpha. Am I right or not? R alpha, right? So there are two types of accelerations. Now I am going to write it as A minus R alpha. Alpha is what here? Alpha for the lower cylinder, we have taken it as alpha 1. Am I right? Now, similarly, acceleration of point Q. Acceleration of point Q is what? Acceleration of point Q is simply R into alpha 2. Because there is no translational motion for this. Translational acceleration will not present here. Therefore, according to this constraint equation, we can say that AP is equal to AQ. Acceleration of point P is equal to acceleration of point Q. So let us write these two values. A minus R alpha 1 is equal to R alpha 2. A minus R alpha 1 is equal to R alpha 2. So we have got this equation also, fourth equation. So finally, what are we getting? 4 equations in order to solve 4 types of unknown variables, 4 unknown variables. So let us substitute all these values in this fourth equation, second equation and third equation, alpha 1 and alpha 2 values. Let us substitute in this. So substituting equation 2 and equation 3. Equation 2 and equation 3 in equation 4. So what are we going to get now? A minus R into, what is alpha 1? Alpha 1 is 4t by mr. Okay. Is equal to R into alpha 2 value, 4t by mr again. It's not. Okay. So now let us take A is equal to, send this R into, here RR gets cancelled and here also RR gets cancelled. 4t by m minus 4t by m, and let us send this to minus 4, let us send this minus 4t by m to right side, so that I'm going to get 4t by m plus 4t by m. This is 8t by m. 8t by m. I have got the acceleration. Now what I need to find, only tensional force is asked. Am I right or not? So I'm going to substitute this A value in equation 1. Substituting, shall I write here? I'm going to write here once. Look at this. Substituting the value of A in equation 1. So mg minus 2t is equal to m into acceleration is what? 8t by m. Here mm gets cancelled. Therefore, send this minus 2t to that side. Mg is equal to 10t. Because if minus 2t comes to here, comes to right side, 8t plus 2t is 10t, right? Therefore, what is tensional force now? Therefore, tensional force on each string. Tensional force on each string. That is, T is equal to mg by 10. T is equal to mg by 10. That's it. This is the tensional force. Okay. Suppose if masses are given, then we need to substitute that mass value and find out what is the tensional force in this. Understand? Once look at this, what we are doing. First, we are taking 2 cylinders. In that, first let us write the translational equation for lower cylinder. For that, we are finding out in terms of acceleration of center of mass. Okay, downward force minus upward force equal to mass into acceleration. Later, we are writing the torque equations. And from those two torque equations, I'm writing alpha 1 and alpha 2 values. And later, I'm going to write the constraint relation. This is very important. Constraint relation means what? Here, the 2 points P and Q that I have drawn, they have same accelerations. So AP and AQ are equal. So that I'm writing AP value and AQ value. And finally, I'm going to get I'm going to get a value in terms of t, that is a is equal to 80 by m. And if we substitute that a value in that equation 1, I'm going to get t is equal to mg by 10. Okay. So that's it. This is about the concept. Still, if you get any doubt, please mention in comments section so that I'm going to solve it again. Okay. If you have any doubts, again I can solve. No problem. I mean, I'll solve some other problem which is similar to this. Okay, na? Thank you. And please like, share, and subscribe to my channel, Physics Star. Okay, thank you.